In the previous video, we looked at what it means for a vector function to have a limit. In this video, we're going to look at what it means for a vector function to be continuous. So remember, in 2D, a function is continuous if the limit, as you approach it from the left-hand side, so as you approach it from the left-hand side, so you've got a negative here, equals L. So from the left-hand side, it's heading towards L. And from the right-hand side, so you've got a plus here. From the right-hand side, you also head towards L. You also head towards L. And for limit to be, for function to be continuous, f of a needs to be defined and it needs to be equal to L. So it's no good having f of a equal somewhere up here because it's not continuous, because it's heading towards L, and then all of a sudden it jumps to up here, and then from the left-hand side it's heading towards here, and then all of a sudden it jumps here. It's not continuous. You can't really draw it in one stroke. For it to be continuous, f of a must be defined and it needs to be equal to L. So this needs to be defined and it needs to be equal to L. So the limit. So for a function to be continuous, the limit from the right hand side must equal L. From the left hand side it must equal L, and dead on A it must also be equal to L. So now it's continuous. Now extend it to 3D. So let's just imagine this L here as a point floating in 3D space. So imagine it as like 1 across, 3 across, and then 4 up. So imagine this L as a point floating in 3D space. Just imagine it as something like this in your mind. Okay, so 1 across, 3 across, and then 4 up. Just imagine as that. Imagine this L as floating in 3D space. So for a vector function to be continuous, from the left-hand side, so meaning negative time, from the left-hand side, as you approach t0, it is heading towards L. And then from the right-hand side, as you approach t0 from the right-hand side, so from the right-hand side, you're heading towards t0 here, so we should be here, and then it approaches L, and then it needs, dead on t0, it needs to be defined and it needs to be equal to L. So there's no point having this being located at, let's say 1, 2 up, 1, 2, and then 7 up. So it's no good having t0 equals here. You need to have t0 to be defined and it needs to be equal to L. So now it's continuous. So now it's continuous all the way through. So for a vector function to be continuous from the left hand side, meaning t heads towards t0 from the left hand side. So negative time heading towards t0 is heading towards L. From the right hand side it's also heading towards L, and dead on t0 it equals L. It equals L. It needs to be equal to here. So now it's continuous. Okay, so for it to be continuous, it needs to be L. Approach from the right hand side, it's L, and dead on t0 it equals L. Then it's continuous. Okay.